In this short video, what we'll do is we'll try and value a cross-currency swap, and this time we'll try and do it using two methods, the same way as we did for interest rate swaps. And these two methods are number one, the one which involves bonds, and number two, the one which involves estimation of forward exchange rates. And what we'll try and convince ourselves is that both these methods give you the final valuation, which is the same valuation. Okay, so let's begin with the first method. That's the easier one, and that's the one in which we do it via bonds. So let's read out the question. So it is given that the term structure of interest rates is flat in both US and Australia, and respectively they are 6% per annum in USD and 8% per annum in AUD, both of which are continuously compounded. So let's note it down. So R in USD is 6% and R in AUD is 8%. Then the current exchange rate is given to be 0.64. That means X at time T. I'm standing at time T. It's given to be 0.64 USD per unit AUD. So 1 AUD is equivalent to 0.64 USD. Under the terms of the swap agreement, a financial institution pays 7% per annum in AUD and receives 3% per annum in USD, with principals in the two currencies being 15 million in USD and 25 million in AUD. The frequency at which these payments are exchanged is once every year, with 3 payments left, one at the end of each of the coming 3 years. What is the current value of the swap? This is to this financial institution. So let's draw the cash flow diagram first. So the cash flow diagram would look something like this. There are 3 payments left. I'll draw it from the perspective of this financial institution. So this institution is receiving USD payments. So USD, USD, USD. And it's paying AUD payments. So it's paying out AUD, AUD, and AUD. So this is a cross-currency swap. So you will also have notional exchange at the expiry of the swap. So let's put the notionals also here, okay? So the big ones. So let's try and value it using bonds. I am trying to find the value of this swap at time T, and let's say I am valuing this swap in USD. So let's try and do it. So to value this swap, let's do this first. Let's get the values of each of these cash flows. So this USD payment, it would be 3% because that's the promised interest rate as part of the swap. So each USD payment, let me write it here, it would be 3% this times the USD notional, which is 15 million, this times the periodic, the period, the interest rate period, that is 1. So this gives you 0.45 million. The AUD payment, on the other hand, would be 7% this times 25, this times 1, which gives you 1.75 million. Okay, so these are my respective payments. So to get the value of the swap as of today in USD, I can write it down as it would be like a long position in a USD bond, a bond which pays you a coupon at the rate of 3% and at a frequency of once per year, and a short position because you are paying out AUD payments in another bond, which is a AUD bond of face value 25 million. The face value of USD bond was 15 million, and payouts happen at the rate of 7% coupon once a year. So I can write it down as a long position in a USD bond and a short position in the AUD bond. But these two are in different currencies, so I need to scale them at the current, one of them at the current exchange rate, which is 0.64 USD per AUD, to get it to USD. So that means I will have to scale the AUD leg, let's say. So then I'll multiply it with XT. That will give me the value of this cross-currency swap. So let's do this quick calculation. So the value of the USD bond would be 0.45 0.45 discounted to today. The current exchange rate is 6%, compounded continuously. So it will be 0.45 discounted to today plus another 0.45 discounted to today. So that will be 0.6 into 2 plus the last payment, that will be 15.45, because there will be this 15 million notional return as well. So 15.45 e to the power minus 0.06 into 3. So that will be my USD leg. Then I have to subtract from it the AUD leg, which will come out to be 1.75 discounted to today. This discounting happens in the respective currency this bond is in, which is AUD, and hence I'll discount it at 8%. So it will be 0.08 into 1 plus 1.75 e to the power minus 0.08 into 2 plus 1.75 plus you also need to add to it the 25 million. So that will give you 26.75 e to the power minus 0.08 into 3, and this entire leg, let's scale it by the exchange rate and get it to USD, which is an exchange rate of 0.64. So if you were to do this math, what do you get? In the end, you will get a value of this CCS in USD. You will get it as minus 1.727 million, and this is million in USD. So this is the value of this swap arrived at using the bond method. Okay, so let's now do this. Let's now value this swap again, but this time via forwards. So let's do that. So everything stays the same, and what we need to now do is that instead of discounting respectively the two legs in their respective currencies, let's try and get them to a common currency first and then do the discounting. So that's where the difference lies. In the previous method, we did the discounting and aggregation as of today first in respective currencies, and then we did a conversion into a single currency. In this second method, what we are doing is we are doing the conversion from one currency to another. Let's keep it as converting from AUD to USD. Let's do it at each of the upcoming payment dates, get the net cash flow in USD, and let's perform only one discounting, and that's in USD. Okay, so let's try and do it. Let me repeat the cash flow diagram. So you will have a, let's say, combined payment, which was 15.45. Then you have one payment here, which is 0.45, and you have another payment here, which is also 0.45. Okay, this is year 1, 2, and 3. So in AUD, what do you have? You have 1.75, 1.75, and then here you have 26.75. Okay, so what I'm saying here is that let's convert each of the AUD payments into USD. Let's do it as at each of these payment dates, and then let's do only a single discounting. That means we'll only use this guy for discounting. We will not use the AUD discounting at all. Now, the problem here is that the only exchange rate that we know is as of today. We are given this exchange rate, and this is given to us as 0.64 USD per unit AUD. That's the only exchange rate we know. To get the exchange rates on these 3 dates, we can't get it the actual precise number because it's random. The only point at which these exchange rates are revealed to us is when we arrive at each of these respective dates, not before that. But as far as our valuation is concerned, let's do this. Let's get like an expected value of these exchange rates as of these 3 dates based on the information which we have as of today. So what we want is, let's say, the expected value of this X1 at, let's say, date 1, this is date 2, this is date 3. And we want expected value of this X2, and we want the expected value of this X3. If we are conducting this pricing in a risk neutral world, which I'm assuming we are, This expected value of each of these exchange rates would be equal to the respective forward rates. So this will be equal to F1, this will be equal to F2, and this will be equal to F3. What is the general formula for this forward rate for any currency, for any exchange rate? The general formula is the forward rate as of time t for, let's say, an expiry or delivery at time capital T would be the spot as of today. Let's actually use X. That's what we've been using. So XT as of today times e to the power something. Okay, this times the residual time, which is t minus t. So let's take a look at what is the exchange rate quoted as. It's quoted as 0.64 USD per AUD. Let's treat this AUD to be like a foreign currency, because I am doing this valuation from this perspective of this financial institution, which is, let's say, domiciled in the US. So what would this financial institution treat or calculate this forward rate as, the forward exchange rate as? The formula would look like something like this. This exchange rate is being computed in DC, which is domestic currency. In this case, it's USD per unit FC, where FC here is the foreign currency and that's AUD. So the power here, or like the drift here, would be, it will be R in DC minus R in FC. And in our world, it will be R USD minus R AUD. What is the current rate right now? It's 6 and 8. That means it will be USD minus AUD, which means 6 minus 8. That means it's minus 2%. So let's calculate the three forward exchange rates. F1 would simply be 0.64 e to the power minus 2% into the time, which is 1. This gives you a value of 0.6273. F2 similarly would be 0.64 minus 2%, this time into 2 years. So this you can check. It will give you a value 0.6149, and F3 it will come out to 0.6027. So let's use these exchange rates, get the AUD converted into USD at each of these three payment dates, and let's do one discounting. So let's write down the value of the swap. So it will be V as of today computed in USD. It will be 0.45 minus 1.75 converted at this rate, which is 0.6273. Okay, discounted to today. That means e to the power minus 0.06 into 1 plus the second one. It will be 0.45 minus 1.75 converted at this rate. That will be 0.6149 discounted to today, e to the power minus 0.06 into 2. And the last one, that will be 15.45 minus 26.75 converted at the third forward exchange rate, and that's 0.6027 discounted to today. That means 06 into 3. If you punch in these numbers in your calculator, you can check that you get the same value, which is minus 1.727 million. Okay, so this was my second approach. In this, I did estimate the forward exchange rates, and then I discounted only once, and that was in USD. And we've checked that the valuation which we get for this cross-currency swap is the same as what we get using the bond method.